Welcome to the last talk for today, or the last main talk. We still have one lightning talk after me coming. This one will be a little bit shorter than the one before, but it also will be mostly live coding. So if you already grew fond of compile errors, we will see way more right now. We will see segfaults and all those nice things in Swift. So let's take a look into a new library called Interstellar. So first, something about those who don't know me yet, which is, I think, not that common. My name is Jens Ravens. I'm working at a company called Nerdgeschoss, and we work on all those nice little new things. And one of them is actually something that helps me building prototypes, but not only prototypes, but also real applications really, really fast. And this little something is called Interstellar. So you might have heard the talk from last November about the first version of Interstellar. And we are pretty close to release the next major version, Interstellar number 2, which is a complete rewrite, taking care of all those nice new things in Swift 2 and Swift 3, which will be coming. So it is currently available on the beta branch on GitHub, so if you want to follow along, you can also get it there. But now actually to the fun stuff, which is live coding, of course. So I've prepared something here. So let's switch to the presentation. Or not switching. That looks good. OK. So I've prepared a playground which is supporting Interstellar. So it's basically just our CocoaPods project, everything set up. So I have actually an auto-completion. And so let me look at my notes to actually show what we actually talk about. So Interstellar, for those who haven't seen it yet, is a library for functional reactive programming. Where we take the term functional with a grain of salt, because you can completely use it without being functional, being pure. You can just use it as a reactive library as well. So if you've seen the old version of Interstellar, that was mostly built on results and signals. And to start with that, both are gone in the next version. We will have something completely new, which is called an observable. So let's start with something easy. Let's have a number which is an observable of, for example, 0. So what do we have here? We have a new object, or actually a value type, with the initial value of 0, which might change over time. For those who knew the old version, we had signal, which was mostly doing the same thing, but including error handling. Observable is way more to the ground. It's just an observable thing that you can subscribe to. So let's do that. So let's do something like every time the number changes. So let's do a subscribe, which is new value in, and then just print that new value out. So also opening this, so there we see down at the bottom, we print the value because observable also stores the initial value. So as soon as you initialize an observable, it stores the current, and it will update every time it changes. So let's update that number, because number updating is so much fun. So let's call update on it. Now the next value is 2, and as soon as we run it, you see that the block will be called twice. First for the saved values, second time for the updated values. So that's basically what observables are. If you think this is handy, yeah, you're right. That really makes a lot of programming a lot easier. So we have numbers, we have observables, and observables are pretty much generic by their name, and they can take any kind of object, either value or reference type. So we are not constrained to any objects there. So you can put in a string, you can put in a number, you can put in your model object and observe it everywhere in your application. So for example, have an observable of the current user on your app, and as soon as the user logs out and a new user logs in, you can get a subscription callback and just act on that subscription. So back to my notes. Because we take this term functional in the name, we should of course do something functional as well. So let's start with something easy, which is doubling of numbers. That's something I can do. So let's do a map. So a map is, for those who only have seen it on array so far, basically a generic term in functional programming. It's a box of something, you grab inside of the box, you apply it to that box, and then you put it back in the box. Which works for arrays, which works for optionals. If you haven't used map on an optional yet, you really missed something in Swift, so you should take a look in that. So we map, we have the value, and then we return the new value, which is a value times 2, and assign that to a new variable. So now we have two observables. We have the original observable, which will still trigger that block here. And in this block, we still have a non-doubled value, of course, because we are subscribing to the original observable. Observables are almost immutable in terms of that you cannot change the behavior at runtime, but only the value, which is kind of semi-immutable in my opinion. So what is doubled? Doubled is an observable of int, of course, because we return an int here. So everything here is managed by type inference. And of course, we can subscribe to doubled as well. So this time doing it a little bit shorter is by printing the first argument. So this one is called just one time. So first, observable 0 prints the value in the subscribe block, then we do an update, and the second time we subscribe to it, we only subscribe to the initial value, but we do not do an upgrade. Okay, so far for the basics of observables and what you can actually do with them. So let's get on to a little bit more interesting thing, which is subscribing and nested objects. Maybe you have this very expensive calculation that you have to do from time to time, and you have all those callback blocks scattered around your code. This is the point where we actually start to get something really useful out of this library, when we start to deal with asynchronous code instead of callback blocks using observables. Okay, so we have our number object here, and let's just define a new function. And this new function is a function called double async. It takes a number, and it returns an observable of int. So basically, it's returning an empty, shallow response, which will later be filled, pretty much like a promise. So one thing you can see here, observables are promises as well. So our new observable we are creating is an observable of int that we open with first nothing, just return it. Okay, so the function has happy here. As I've told you, this is pretty much what a promise is for. And one issue in Interstellar 1 was that it was really easy to create retain cycles because dependencies were not resolved after they've run, because signals are meant to be run several times just as observables. So now we have this new thing called options, which you can supply. And we have this new option called once, which will pretty much do what it looks like, and that is turning this observable into a promise. To the outside world, you don't know if it is a promise, if it is an observable, and actually you don't care, because it's something that will run later. And observable will take care of nilling out all the callback blocks and resolving all the retain cycles in here. Okay, so let's write our actual code, which is dispatch async dispatch get. Well, let's just get to the main queue async and then call observable update to our value, which is the number times 2. There's so many ways of multiplicating numbers. Okay, so now that we have our function, we can actually have our double thing as number.map with double async. So we just supply the function as a parameter to map. And what you actually see in here is that we have an observable of int, which is probably not what you want. You want something which just is an observable of something, because otherwise you would have to do something like double subscription, which would look like this. So we call subscribe on it, and then take this, the content of it and call subscribe in it, and then do the print. This is not really nice, and it even gets worse if you do multiple invocations after another. And that's why we have this really nice function called flatMap, which will just flatten the whole stack of observables into a single observable. So we can get rid of this subscribe here and just print that stuff. So now when I update our number and wait a short moment, and wait a little more. Playgrounds are so much fun. Oh, come on.
Did you forget the term that the playground runs in Flip?
Oh, yeah. That's true. Let's just copy that over. Oh, yeah, recording doesn't work. So much fun. Okay. There we go. Yeah, so now that we are asynchronous, we of course need the playground to work for a longer time. So there we see the subscribe on our observable, first for 0 and second for 5. And there we can see the, how we can update the content of our observables and numbers. Okay, so far for asynchronous stuff, which should be pretty handy for all those callbacks from system libraries. So you might ask yourself, if you used the old library, where the result and error handling is gone. And it's actually still there, and we can make it a lot nicer now that we have protocol extensions. So let's change this thing here a little bit. We have our new function, double that number. Because sometimes doubling numbers goes wrong, who knows. So in here, I will just return the number times 2. But maybe it will throw someday, but we just mark it as throwing. So now that we have this new function, let's go to our new doubled. So number.map double that number. What you see in here is, if we check the type of doubled, the type now is observable of result of int. So the new type system is just inferring that this is a throwing function, of course, so it will return it into result, because we cannot store errors for later otherwise, so it's returned into result. And this result then is transferred into the observable, so we can check on that and just do doubled subscribe print 0. And there you see we actually have a result on here. So if you have multiple functions which might fail, we run into the same issue we had before, where you had this observable and an observable. Now we can have, if we do multiple versions, an observable of result of something, which is also not what you want. A lot of people complained that calling an operation to flatten that down is not semantically correct flat map. And that's why there's a new function for that called then. You might know then from JavaScript, our second favorite language. And then it's pretty much that what the old flat map was on Interstellar. So if we look on the type of 0, it now actually is an int. So then is a protocol extension on a generic type constraint, on a generic struct contained in a class. So if you ever want to write something like that your own, it's a lot of fun. There's so many ways to crash the compiler. The whole Interstellar version 2 is around 100 lines of code, and took me a few weeks to write them, because mostly the compiler was failing. And there's so many ways of making generics go wrong. So you can do a lot of experimentation, but also it's really nice because you learn a lot about the compiler on the way there. So then is chainable. So do this, do then something else. And there you can just chain all those operations, and as you can see here, the last operation returned void, so the next content of then is actually an empty error. So in the end, you can then catch the error. So in the end, we can tell if something went wrong on the way. So what you can do with this kind of programming is that you can handle asynchronous code, which might fail in a way how just like Unix is doing that on a command line, where you just pipe together different commands, and then you go just from cut to grep to whatever command, and then just transform all that stuff on the way. And in the end, you check if you actually have a result or if you have an error. Okay, so far for results and all that stuff, so let's make something more interesting, and that's a new addition in Interstellar 2, or something that is based on it. And that's, so make this thing a little bit faster. Okay, so there is this really nice thing where you can assign view controllers to playgrounds and then see what works. So let's see if we can do that today. So we have our new Hello View controller, which is a UI view controller, of course. And there we have a label, which is a UI label. Well, let's just initialize it in viewDid load called super, and then do some adjustments on here. So label.frame will be CG rect. What was it? Okay, so X, Y is 0. Width will be view bounds width, and height will be 40 pixels. So view at subview label. And then page live view will be Hello View controller. Put it over here. Okay, this view background color is color. Yeah. So we have our view controller. We have a label on the top, which is currently not displaying anything, just to prove that it's there. There we are. So now we have a view controller. And we can just edit that live without recompiling all the time. So let's do something nice in here, which is adding a text field. And you know, all text field handling can be so much fun. So text field is a UI text field. The frame will be just with an offset, just right under there, and oh yeah, we have to add it, of course. Subview text field. Yeah, yeah, whatever autocorrect is saying, other, I guess that's something interesting. Yeah, so as you can see, since Xcode 7.3, we actually have live previews of view controllers and actually having them interactionable, which I think is one of the coolest things we had in the last update. So now you can do all these funny things in here. So what I actually wanted to do is building this hello string there automatically. So I want to listen to the delegate of the text view when it changes, and then manipulate that and then assign it to the label, which are like a few lines of code, but still pretty much boilerplate code. And that is where this new library called Holodeck comes in. So Holodeck is a wrapper around UIKit currently, implementing all kinds of interesting signals on them, or observables in Interstellar 2. So let's take our text field, use our text observable. So it is an observable of string. So every time the user types, this observable will update. And just start with subscribe. So let's do something easy for the beginning. Open the debugger. There you see all the events coming in, flying from the keyboard. It might be, so if you're implementing something like a real text or real-time search, it might be a little bit bad to make all those API requests while the user is typing. So usually you have something like a debouncing function. And that's something we have, of course, as well, and just debounce it to 0.7. So now we do at most one request every 0.7 on the way. So there you see, actually we do all the thing of debouncing in here. Okay, so we have debouncing, that's nice. Let's make something else. Let's do a transform on here. We transform by this new function which just returns a string saying hello, whoever that is. And now we call this new function called bind. Bind is a function that takes whatever object implements a protocol called model representable. So everything that is okay to represent a certain kind of model can implement this model representable, and for label it is implemented as text. That's like the most basic thing. A label can display text, so it implements model representable for text. So we can just bind it to our label. So what we did here is we take the text field, take its observable of the text, map it via our function here, bind it to the label, and actually get code checking all the way through, having strong types all the time. So that's a way of handling a lot of interaction between users. So you take all the user interaction as a stream of events and stream them from their source through some transformations, which might be async as well, and then bind them to a destination where they are displayed. So we still have a few moments left, so I can go to my favorite last example. Because it was so much fun displaying all those numbers. So here, we had this model representable, and there's one bigger protocol which also implements model representable, and that is model cell. A model cell is anything that is a UI table view cell or UI collection view cell, and that is displayable in a collection view or in a table view. So now that we have this display cell, it needs to have an identifier so we can find it, and it has this update model class where it actually defines which kinds of model it might take. So in this case, it takes an int because it can display an int as a string. And now just do a little bit shorter thing, and that is our new table view controller, which will be a UI view controller. It is a table view I table view, and also it has a model. Let's just call it numbers, and that's an observable of some numbers. Okay, so again, our view.load so table views are numbers observables. Oh, yeah. So the table view frames is the views bounds and view at subview table view. Let's display this thing. Live view is a table view controller. Okay, that looks nice so far. Let's wrap this thing in a root view controller so we actually have something there. And there we go, we have our root view here. Let's also set the title to Hello Swift Berlin, so we can actually see what happens in here. Okay, so we have a full view controller stack up here, and we actually want to represent all those numbers in a table view. And actually, the type system has all the information it ever needs to display everything. So we just have to wire it up. And that is by calling let adapter table view create adapter of a cell type. So we supply what kind of cell we want to render. That's a UI. That's a number cell dot self. So we have our new adapter. Our new adapter is of model type, whatever that model type of the cell is. That's actually int. And our number cell, which is our cell in here. And then we can call bind on our numbers bind to the adapter. And there we have our numbers in the table view. You can do that for arrays. You can actually do it for everything that is representable as an observable. And to make this a little bit more interesting, let's add one last function, which is, let's call it shuffle. So this function, when invoked, will just shuffle the array a little bit by just taking the first number and appending it at the end. Or doing it the other round, taking the last element and appending it in the front. So our new numbers is numbers.peak. So peak is a method to get into the results of the observable, and because this is a saving observable, you can just safely unwrap it at that time here. Let first is new numbers remove last, and then new numbers insert first at index 0, and on the numbers call update new numbers. Okay, so last thing we have to do is to wire it up. So let's just create a new navigation item, and that's by navigation item, right, bar button item, UI bar button item system. So it's net, something like that. Well, maybe let's just make it. Let's stay with that. It targets ourselves, and the selector is shuffle. Okay, so now we can do that dance where it constantly corrects us, and there we go. And if we click here, as you see, we are not calling anything on the table view. The table view is bound to the numbers observable. So every time the numbers observable is updating, the table view is doing that as well. So you can just click through all those numbers in here and just add your own table views code there as well. So what is Holodeck giving us? It's mostly removing all the glue code we have to write constantly, and it gives us reactive updates on our complete UI. The main question is, where is this library right now? And that's the answer to that is it's in really its infancies. So we have observable here, which is, I think, in production at artsy since yesterday. So they're already testing the new branch, and they like it so far, and it works. So it is kind of production safe. It will be released within the next few days. Holodeck, on the other side, is like really, really new. We just have a few basic bindings. So we have buttons, we have labels, we have table views, we have collection views. We do not have automatic animations on the updates yet, which is mostly due to the diffing algorithm handling ints a little bit strangely. But we are really at the beginning, and this is the part where I would like you to join, is to wrap everything in the foundation, in the UI kit, in all those libraries, in observables, so we can start doing this declarative coding and do something like numbers bind to an adapter. Okay, so that's so far from my side. Are there any questions on this topic?
Am I getting this right, that everyone having a reference to the observable can update it?
Yep.
Oh, okay, I got it. Thanks.
Yep. So it's not really private, or there's not really access control on it. Everyone who has a handle of that observable can update that. We have an ongoing issue where we think about different ways of wrapping observables in objects, where you can, where the receiver of the observable cannot update it anymore. But that's like just at its beginning. But it might be in the library later on. Thanks. Anyone else?
Why call update when you first subscribe to an observable?
When I first subscribe to an observable, so usually you are interested in the initial value of it. So we had a really long discussion about that. It was one of the different decisions in Interstellar version 1 compared to all the other frameworks on the market, that we save the initial value, and as soon as you subscribe to something, you get the initial value. And actually, it's preventing a lot of bugs where you subscribe to something which isn't there yet. So if you subscribe to something which is, other way around. If you subscribe to something which is not there yet, and then the update happens, everything's okay. But if for whatever reasons the completion or the update is called first, and then you subscribe a little bit later, which happens as soon as you do concurrency on all different ways, you actually miss that value, although you might be interested in it. If you don't want the initial update on it, so if you see this here, numbers bind is calling subscribe under the hood. So you want to be informed about the initial state, so we can set up the table view. If you don't want to have that, you can just call options, no initial value. And then the initial value is not rendered, which would lead to this kind of visual glitch, where the table view is empty until the first time you modify something, or actually it's breaking at that point. So yeah, you actually cause more bugs by not having the initial value. That's the reason why it is in there.
Okay.
Hey, but that's not the case for all subscribers, right? Because you did the double map, and the double map did not receive the initial value. Is that correct? Previously?
Sorry, what was the last part?
In the example before that, where you were implementing the numbers.map and you were doubling the numbers, I think that subscriber did not receive the initial value.
So it's not about the initial value, but the last saved value. So an observable always saves the last state, unless you tell it to do otherwise. And therefore, the first update was 0, which is saved. Then we updated it to, I think, 5. So then 5 was the last known state. And the moment we subscribed, we didn't get the 0, but the 5, which was the last state. So when we map over it and we subscribe to the next variable or to the next observable, then this next observable is referenced by the first one, which still has the 5 in memory.
Okay, thank you.
Am I right that you are not using Xcode interface builder because it does not fit completely to the interface builder? But my question is, would it be possible to think about
Interface builder?
Interface builder to add
so my favorite tool in Xcode is Interface Builder. So maybe I can just stop you at that point, because everything in here is mostly built so it can be used with Interface Builder. Because I'm myself I'm a huge fan of it. So that's why actually table view controller or the table view is not a generic thing, which most implementations do, because generics are not supported by Interface Builder. And that's why we still use Interface Builder and have this adapter in between, which we could save if we wouldn't want to support Interface Builder. And so the adapter is actually taking care of all the generics in the background. We lose a little bit of type safety on the way, but I think that's kind of a fair trade.
Okay. Thanks.
Okay, thank you.